Hello and welcome to our 6-week Tuesday wrap-up. This week found us focusing almost entirely on the central limit theorem. And if I had to explain in one sentence what the central limit theorem means, it means get a larger and larger sample size, right? For example, if I want to know if my coin is fair, right? Fair meaning that heads should show up 50% of the time, tails should show up 50% of the time, right? So if I take the coin and I flip it 2 times, is that going to give me a good idea of whether or not I have a fair coin? Okay? 2 tosses is simply not going to be enough, right? It could land on heads both times, and that would make me think maybe it's a biased coin, right? Because it landed on heads 100% of the time. But 2 is a very small number, right? What if I were to flip that coin 500 times? If I flip the coin 500 times, I would guess that heads would show up very close to 50% of the time, and tails would show up close to 50% of the time. I doubt that they would be exactly 50% each. But the longer I flip, or the more times I flip, the more accurate those percentages are. So if I could flip a coin 1,000 times, it should be even closer to 50-50. Okay? So just to review here, it says the central limit theorem for sample means says that if you repeatedly draw samples of a given size and calculate their means, those means tend to follow the normal distribution. Now I used percentages, and we could use the central limit theorem for percentages or averages. So what about average? Well, suppose the average height for a male, for an adult male, is 69 inches. I happen to be 69 inches tall. I am average. But if I wanted to do some sort of research on average height for men, would I only measure the first 2 men that happen to walk by? Of course not, right? They could be basketball players coming out of the gym. They're going to be unusually tall probably, right? So what should I do? Well, instead of measuring 2 randomly selected men, I should maybe measure 50. If I want an even more accurate estimation, an estimation closer to that 69 inches, maybe 100, 500, maybe 1,000 men. The point is, the larger the sample, the more your outcome is going to mimic the actual population parameter. I hope this helps.